And welcome to the Daily Space Weather. We've got another M-class flare and lots more stuff to cover. That image there, that's a series of images from the SDO. It's the ionized helium wavelength, 304 angstroms. And let's get to it. So that's the last 24 hours. Again, we did see one M-class flare and some coronal mass ejections happening as well. We're expecting to see more coronal mass ejections. We've got new sunspots having risen down here. This is a new sunspot group. We'll have at least 6 named sunspot groups today. And let's show some even more detailed imagery of the closest star. So here's a zoom in. We've added 171 angstroms to the ionized helium, so ionized helium and ionized iron there. A picturesque scene of massive filaments, coronal holes, sunspots. And to give you an idea of the perspective, a great view of the Earth scale. So lots of interesting stuff going on. Again, we're expecting additional coronal mass ejections. The radial flux now up to 169 solar flux units. We are not at the peak of solar cycle 25 yet. We haven't gotten back up to 180. That was the highest we've been. And that occurred back in February? Back in May. Back in May, we did see the radial flux make it up to 180. Now we're up to 169, so we're pushing those tops that we've seen back in May. So there's a space weather enthusiast dashboard. No geomagnetic storms or geomagnetic unrest forecasted. And let's continue on here to take a look at the earthly geospace for the last 4 hours. We do have a heightened solar wind speed here. We've seen a elevated solar wind speed over the past 24 hours from a coronal hole high-speed stream. We reached nearly 600 kilometers per second. We'll get to it. This is the last 4 hours of magnetohydrodynamic pressure, Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. We show it daily on the channel since it's not visible in archival form. Here's Earth's magnetic moment from the ground. Our ground magnetic perturbations map here showing magnetic flux density in nanotesla. Earth's magnetic moment from the ground for the past 4 hours. And lots of exciting stuff going on today once again, as the sun does not disappoint. Now, something going on with the KP index. Not exactly sure, but if you go to the Space Weather Enthusiast dashboard, you can bring up this image. There's the estimated KP. And the estimated KP now looks like we're going down to a KP of 0 at the moment. Something like a KP1. That's a measurement of global geomagnetism. So here's your real-time solar wind data. It has subsided a bit. Again, we reached nearly 600 kilometers per second yesterday. There's a reading of 587. Current conditions are a little bit slower than that, about 560 kilometers per second for the solar wind velocity. Solar wind density, 12 protons per cubic centimeter. And let's continue on to look at magnetic data. There are the data from the GO 16 and 17 for the past 3 days. You can see some sawtooth readings there. There is high-speed plasma affecting the magnetometers. And as we forecasted yesterday, Earth has snapped into a South Pole current sheet. So the plasma coming from the sun is oriented to one pole or the other. This is the South Pole current sheet. There's the North Pole-oriented current sheet there shown in green. And again, Earth has snapped into a South Pole current sheet since yesterday. We can expect some lower readings on the GOES magnetometers based on what I see on that top view ecliptic plane field plot. So here's the line of sight field plot. Again, we've got new sunspots having risen in the east, close to the equator, are those new sunspots. And again, we're expecting to have at least 6 named groups, some of them major groups. We've had some solar flares as well, another M-class flare that we'll cover momentarily. First, coronal holes. There's our coronal hole plot. We've got some new South Pole-oriented coronal holes rotating in here in the east. We'll let that play through, and then we'll show 193 angstroms from the SDO. And you can see those getting more well-defined here as they rotate toward Earth. If you're wondering what 193 angstroms, it is the ultraviolet emissions from a specific species of ionized iron. It's great at showing what we call coronal holes. Areas in the solar corona where there are not a lot of those particular iron ions. Huge filaments on the Earth-facing side of the solar disk. We'll get to that also in a moment. First, sunspots. So likelihood of solar flares very, very high. We did see an M-class flare come from sunspot 3058. And as sunspot 3053 and 3055 approach the western limb, they're more likely to produce major flares as well. Flare probability just very high. We've got a new sunspot down here. That'll be known as 3059. And you can see how close to the equator that is. It's a tropical sunspot. Continuing on, some visuals. It's the SDO 1700 angstroms wavelength. And here's your continuum, your visible light. So major sunspots dominating the earthly portion of the solar disk. And huge filaments anchored in the solar corona. Here's a close-up in that same visible light spectrum. Spectacular high-res imagery there from the Solar Dynamics Observatory. Thanks for stargazing with us. We are delighted to have you. Plenty more to cover here on the Daily Space Weather. Peak flux of this M-class flare, and it was an M2.89, so nearly an M3 flare. Peak flux was around 2140 yesterday on July 14th. Don't be surprised to see X-class flares. We've got more than enough sunspots to produce one, maybe even more than one. No relativistic particles from the most recent activity we've been seeing. No spikes in the proton flux. A great wavelength to view solar flares is certainly 94 angstroms, and you'll see this M-class flare coming out of sunspot 3058. Great view of that. We'll let that play through again for you. That is some good stuff. We encourage you to go outside and look up. If you're up before dawn, you may see things like Venus in the morning sky. And Mercury is becoming an evening star. Or I should say an evening planet. Again, make sure you go outside and look up. Let us know what your favorite star is in the comment. We'll also do a solar system forecast. We've got a gibbous waning moon at the moment. We hope you enjoyed full moon. Here's where things will be in 1 week. Here's where things will be on July 22nd. We will have a crescent waning moon by then, as Mercury swings around to the far side of the sun. So here's some coronagraph imagery, and we do indeed see some coronal mass ejections. They do not appear to be earthly directed. That's all day yesterday's coronagraph from the George Mason University data set. We'll also show today's imagery. And there are today's coronagraphs. Some additional coronal mass ejections showing up there. Also not looking like it's headed toward Earth. Just to show some additional perspective here, we'll also show the view from Stereo A's coronagraph here at Lagrange 5 and the Soho Lascaux C3 here at Lagrange 1. And for you new viewers, Earth is off on this line from Stereo A's perspective. And we should see that none of those CMEs are directed toward Earth. That one's on the far side. So no apparent earthly directed coronal mass ejections at the moment. You can see this one's looking like it's off to the west. I'm sorry, that's the east. Off to the east. This will be the west side. And we call that the west side because that's where solar weather sets. When we see a sunspot set, it sets in the west. Sunspots rise in the east. Anyway, that's what's going on. Expect to see additional coronal mass ejections. We've got likelihood of solar flares very high, likelihood of coronal mass ejections nearly 100%. What's the likelihood of you pressing like and subscribe? We're hoping that's at least 100%. Press like, press subscribe, press share, tell your friends and foes about us. Thanks to our new subscribers over on YouTube. Please visit our links at places like smashomash.com. You can find links to the Smash team there, and welcome to the DR Renaissance. Check us out all over social media. Hit us up on our Facebook group, or if you'd like to send an instant message, there's a permanent invite link to our Discord chat there right on the homepage at smashomash.com. We're all over the internet. Give Smash staff a raise by picking up some Mensa products, where we say to you, make Earth not suck again. It's not a political slogan in any way. It's a pragmatic slogan, one of personal responsibility. It's up to you to make Earth not suck again. Tell your friends and foes about it. Start a conversation. It's up to each and every one of you to make Earth not suck again in your little microcosm. So perhaps pick up some merch, maybe a set of leggings. The spectacular design there featuring Earth, and our website smashomash.org. That'll redirect you to our homepage, by the way. And you can find links again on the homepage at smashomash.com as well as below this video. They'll be linked in order of best selling. If you'd like to support the channel via subscription services, become a member of the Smash team. Smashomash.com/Smash team. That's our Twitch channel there. We're actually not live at the moment. However, we will be soon to monitor the closest star. It's a great screensaver. And thanks to our gold and silver Smash team level members. By the way, were you aware that we already informed our gold Smash team members of the mechanism underlying the solar sunspot and solar polar field reversal cycles? Yeah. We've already divulged the mechanism behind it in preparation for releasing a paper about it. It's kind of important. Thanks to our Twitch followers. Some new followers over there on Twitch, twitch.tv/smashomash. Such a fantastic live streaming platform. Download the mobile app, YouTube viewers. It will actually allow you to see when we go live. And check out the filaments. We're looking at the hydrogen alpha imagery here from El Teide, Spain, the ground-based solar observatory. And all those dark features there, those are solar prominences. If they were hanging off the limb, they'd be considered prominences. But since they're in between the Earth and Sun, they're what we call filaments. They're absorption features. And that material suspended by magnetic fields in the solar corona could be headed our way at any moment in the form of what we call a coronal mass ejection. They can cause geomagnetic storms and aurorae. They could even cause power grids to shut down if they strike the earthly geospace. So that's what we're kind of waiting for. And once again, these are the most filaments that we've ever shown on the channel in about 5 years. Over 5 years. So some spectacular imagery there from El Teide, Spain. All those filaments could be ejecting soon. So here we see some additional activity happening over here in the eastern limb. You can see some material coming out and then coming back down, it looks like. And occasionally that does happen. Material will collapse back down toward the chromosphere. So some of those filaments could collapse. Some of those filaments likely to eject. We'll be keeping an eye on it. And when I say eye on, pardon the pun. We're going to close things out for this YouTube exclusive in 171 angstroms. So it's the house favorite wavelength. Thanks for tuning in to the most comprehensive space weather videos on the entire internet and the most detailed views of the sun that you'll see anywhere. Thanks for stargazing with us here at the Smash News Network, least busted name in news, and may that solar wind be at your back.